Today we will be going over the USACO 2023 February Contest Gold Division. Problem number 3, piling papers. Farmer John wrote down digits on pieces of paper. For the ith piece of paper, you are given a digit AI. The cows have two favorite integers, A and B. They would like you to answer Q queries. For the ith query, the cows will give you L and R, which are the indexes of the start and end points of the papers. Maintaining an initially empty pile of papers. For each paper, you'll either add the paper to the top of the pile, to the bottom of the pile, or neither. In the end, they will read the papers from top to bottom, forming an integer. Over all 3 to the Ri minus Li possible ways, for the cows to make choices during this process, count the number of ways that result in the cows reading an integer in A and B inclusive, and output the number modulo 10 to the 9 plus 7. This is N, this is A, this is B. These are the digits, number of queries, and yeah, these are the queries. Each one have a digit L and R, which are the indexes of the start and end points where you read and pile the papers. We can use digit DP to solve this problem. The states are the current paper we're on, the left limit position, the right limit position, and whether we're less, greater, or equal to the limit currently. So our transitions are, if we ignore the paper, everything is the same as if we did before we got to the paper. So we just add what we had before. And if we add it to the top, it's going to impact it a lot because the top digit is always the most significant digit. So if it's smaller than the limit, we will always add it to the if it's less, then we're always going to add it to the less position value. And if it's equal, everything's the same as it was before. And if it's more, then it's going to be more because it's the most significant digit. And yeah, we just add everything to the more position. Now we put the paper on the bottom section. So if we put the paper on the bottom, it's gonna be it's not the digit's not gonna be really significant. So if it was smaller originally, it's gonna stay smaller. So we just add the less to the less. And if it's more, it's gonna stay more. But if it's equal, then that means that it will change stuff. And so we have to just determine where we add the equal value. So if our digit is smaller than limit, we add it to the less place, and if it's equal, we add it to the equal position, and if it's greater, we add it to the greater position. And the time complexity of this is O(n) squared log 10b squared. So basically, it's just the n squared times constant factor that's small enough to work. This it's that because we have to do a DP every time before. I mean, we have to for loop every time before the DP. So that will add an extra factor of n. So so we're gonna have a n, and here's an n. This is log 10, log base 10, b. This is also log 10, 10b, and this is just a constant factor. So now we are going to do the code demo. So first we take in the input here. We make A and B a vector of digits. So we can access each digit pretty easily. I did that here, and we have to reverse it, and this is basically the DP function. So this is we pass in the lim. This is the amount of papers. This is the DP. So we first for loop through all of the papers, which is going to be the left bound for papers, and then we reset the DP. And then we have this is just for the current paper we're on. This is for setting the initial values, and because for like when we're on a certain position, when the left bound and the right bound are the same, that means that we only put one paper in there. And yeah, for every one of those, we can have one paper in them. And there's two ways to put two papers in them. You put it in the front or you put them in the back. And we don't do that because we can't and then we have this is the left bound for the limit, and yeah, we do this because you can always get rid of the paper and like you not want it. So yeah, even if the left and right bound are at the same position, you can get rid of the paper. Here is ignoring the paper. You just add whatever value it was when we didn't have the paper yet. And here's when we put the paper on the top. If it's less, we add it to the 0 value. If it's equal, we add it to the original, like the same value, because nothing changes. And if it's greater, we add it to the 2 value, which is the more value. And now is when we put the paper on the bottom. So basically, if it's 0, since it's at the end, it's going to be the least significant digit. So if it's 0, it stays at 0. If it's more, it stays at like 2. And if if it's 1, it's going to be different, and that is determined by the current paper. So we have this, and you have to mod it or else it goes over. And here we're just calculating the answer as we have this for the answer, and we return a vector of answers. But here we basically find a left bound, and the limit has to be at the right bound, because no matter what, you're always going to be comparing it to the right side of the number. And yeah, and here, no matter what, we can always add the smaller value and the equal value. But if k is not equal to 1, which means that our length of the number is smaller than the actual limit length, then that means that we can add the more value, because it's always less. And here we just mod it, and yeah, for each query we get x and y, and we just calculate the answer.